Hey guys! Welcome back to the laboratory. In this video, we are looking at scalars and vectors. By the end of this video, you should be able to define the terms scalar quantity and vector quantity, give examples of scalar and vector quantities, and compare examples of scalar and vector quantities. So, let's go. In physics, any quantity that can be measured can be classified as being one of two quantities. These are scalar and vector quantities. A scalar quantity is a quantity that has a magnitude or size only. Speed, distance, energy, density, and mass are examples of scalar quantities. In contrast, a vector quantity is a quantity that has both magnitude and direction. Velocity, displacement, momentum, acceleration, and force are all examples of vector quantities. Let's explore this concept further with a few examples. Here we have a moving car. If I were to tell you that this car were travelling at a speed of 20 meters per second, then this would be an example of a scalar quantity. This quantity tells us how quickly the car is moving, but does not specify a direction. Therefore, our quantity has a magnitude, but does not have direction. In this example, our magnitude is 20 meters per second. However, if I were to tell you this car were travelling northwards at a velocity of 20 meters per second, then we now have ourselves a vector quantity. Velocity is a measure of an object's speed in a specific direction. Our quantity now has a magnitude and a direction. In this example, our magnitude is 20 meters per second and the direction is northwards. We can use vector diagrams to provide a visual representation of different vector quantities, where arrows are used to show the magnitude and direction of the vector. For example, if we wanted to annotate this diagram to show that our car was travelling at a velocity of 20 meters per second northwards, then we would place an arrow on our diagram like this. The direction of the arrow indicates the direction that the car is travelling, and the size of the arrow represents its magnitude. If we wanted to show that the car had now begun to travel at a velocity of 10 meters per second eastward, then we would update our vector diagram to this. The direction of the arrow has changed, and its size has decreased to represent the smaller magnitude of the vector. Got the hang of it? Let's take a look at another example. Here we have an apple on a table. If I were to tell you that this apple has a mass of 1 gram, then this would be an example of a scalar quantity. This quantity tells us how much matter makes up the apple, but does not specify the direction that this matter is acting in. Therefore, our quantity has a magnitude, but it does not have a direction. In this example, our magnitude is 1 gram. However, if I were to tell you that this apple has a weight of 1 Newton, then we now have ourselves a vector quantity. Weight is the force of gravity on an object that has a mass, and gravity always acts downwards. Knowing the weight of the apple means our quantity now has a magnitude and a direction. In this example, the magnitude is 1 Newton and the direction is downwards. We can now annotate this diagram to give a visual representation of this vector quantity. The vector diagram for an apple with a weight of 1 Newton would look something like this. And that's it, guys. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!